Everyone, in this video we solve the question kth smallest element. Okay, so I would say this question is an important question. Okay, so what we are given in the array, we are given an array, okay, and an integer k, and what we have to do, we have to find the kth smallest element in the array. That means if we are given this array, that is 7, 10, 4, 3, 20, 15, we have to find, if the k value is 3, we have to find the third smallest element. So the first smallest is 3, it is the first smallest, it is the second smallest, and it will be the third smallest. Okay, so we have to return the value of the third smallest element in the array. So it is a basic question. What is the naive approach, or we can say a brute force approach to solve this problem? We have the array. What we can do, we will sort the array. Simple sort the array and return the k minus 1th element of the array. That means if the we have to return the fourth smallest element now, so it would be present at the third index. So we'll return the element present at the k minus 1th index after sorting the array. So this is a simple approach. It requires a higher time complexity. Okay, it requires a time complexity of n log n. So it is not a good time complexity to solve the problem. So we'll try to approach this problem in more optimized time complexity. Okay, so what have we have this, the optimized solution to solve this question. So we have the array and we have to return the third. For this sample test case, we have to return the third smallest number. So here is some intuition or note which we will look at. Whenever you will find a question in which you will have to find either the smallest, kth smallest, or the kth largest element, then we have to use the heap data structure. Okay, to reduce the time complexity of the problem, we have to use the heap data structure. Okay, whenever we see a question of this type, that is we have to find the kth smallest element or the kth largest element from the given array, we have to use a heap. Okay, if the question is to find the kth smallest, if the question is to find the kth smallest, then we will use a max heap. Remember this. Okay, if the question is to find the kth largest element, then we'll use a min heap. Okay, this is a theoretical part. Okay, so what is a max or a min heap I am talking about? If you do not know the heap, I recommend you to first uh, learn or search about the heap, how it is implemented. This is just a brief overview about the heap which I have given further. So in min heap, first of all, we have the min heap. So how the array element are stored in a min heap? So it is a min heap. Okay, so a min heap is like that. We have the smallest element at the top, then we have the second smallest, then we just care about the top. Okay, it is similar to the stack. We always care about the top element, we does not care about the beneath element. Okay, the top would be in a min heap, the top would be the smallest element in all the elements that are present in the heap. Simple. In the max heap, it is same as the stack, but the same features, it is implemented, it is used as a stack. Okay, we perform the push and pop operation just like the stack. Okay, so but in the max heap, the top element would be the maximum of all the elements that are present in this heap. Okay, now this is the theoretical overview. How will we implement this in C++? Okay, so in C++, max min heap is uh, min heap is implemented using priority queue, in which we have the priority queue and we have the data storage. This is the full format to represent a min heap. So basically, what is the we use a priority queue. Okay, we have a priority queue. Then we have the data type. Let's suppose int. Then we have a vector of int as the second parameter. Okay. Then we have the comparator greater of int. So this is how we form a min heap in C++. And the max heap is simply implemented as priority queue data type, that is particularly int, and this much. So then we have a max heap. Okay. So this is a min heap, then this is a max heap. So if you are given to find the kth smallest element, then we will use a max heap. This already I have told you. And whenever you are asked to find the kth largest element, we have to use the min heap. Okay. So in this particular question, we are asked to find the kth smallest element. So in the smallest element, we're gonna use a max heap. Okay. So let me do a dry run over the given array and convey this idea of using a max heap here. Okay. Okay. So we have to find the kth, that is the third smallest element in this array. We are using a max heap. Okay, we are using a max heap. We'll iterate this array. Whenever we found the first element, we push it into the max heap. We check for the size of the max heap. Okay, if the size of the max heap, if the size of the max heap is the size of the max heap is greater than k, then what we'll do, we'll pop an element from this min heap. Okay, if so, we'll iterate over the array. This is the algo. We'll iterate over the array, store element in the max heap. If the size of the max heap become greater than k, then you will pop an element from the max heap. And after iteration, so I will first iterate. These are the steps, and after iterations, these are the further steps. Okay, so we have 5 as the first element. Is the heap size greater than k? No, it is not. Let me draw a bigger heap. Okay, this is a heap. We have 5. Then we store 4. So the max heap store the maximum element at the top. Okay, now we have 5 at the top and 4 here. Is the size greater than k? No, it is not. Then we push one more element, this element 10, because we are iterating over the array na? Then our top will be this. Is the size of the min heap become sorry max heap become greater than k? No, it does not. We move to the next element. Okay, move to the next element, and now the size of the min heap become greater than k. Sorry, size of the max heap become greater than k. Then we push an element, out of this max heap. Okay, we'll push the popping and pushing of the element should always be just similar to the stack. Okay. Okay, this is exactly similar because in it would be exactly similar that the operations that we perform in a stack. Okay, so whenever the size of the k become greater than size of the max heap become greater than k, we pop an element from the max heap, and the popping should be takes place from the top. Okay, so this element would get popped. We move to the next element. We push it into the stack. It would be at the top because it is the greater element. So the size is greater than k. We pop this element. then we have the element 3, then we have the element 3, so we have 3 here, 1 here. Okay, yes, the size is greater than k. We pop this element, and at the end of the after the iteration of the array, what we'll return the top of it, because this would be the kth smallest element in that particular array. Okay, so after iteration we have to return the top of it. Okay, so this requires a time complexity of order of n, because we have to iterate over the array. It requires a order of n time complexity. Okay, but it requires an order of k space complexity, because at a particular time, at max, we can have at most k element in our max or a mini heap. Okay, we can have at most k element in our heap. Okay, so this is the particular approach to solve this problem. So if the question will be slightly modified, as we have to find the kth largest element, then we just have to follow the simpler approach. We use a min heap. In this case, for the largest element, we use a min heap. We push the element in the min heap and check if the size of the min heap become greater than k. If the size become greater than k, we pop the element from the min heap, and after the iteration return the top return the top of the min heap. Okay, so this is how we solve this kth largest and kth smallest type questions. So let me show you the pseudocode for it. Okay, let me show you the pseudocode for it. So we'll iterate this as the given array, which is received as a parameter to us, and n is the size of the array. So we'll iterate over the array from 0 to n, and we have a min heap. So let's suppose for this particular question, we have to find the kth smallest element now. So we use a max heap. We have a biotic heap. I am writing this pseudocode. Okay, I am writing a pseudocode, or yeah, I can simply write it as max heap. Okay, I have a max heap here. So I push an element in the max heap. Okay, push an element in the max heap, and after pushing, I will check the size of the heap. If the size of the heap become greater than k, then I will push an element, pop an element from the heap. Okay, I will simply pop an element, and after the iteration, I will return the top max heap top. Okay, so this is the good question. I would say this is a good question. If you do not know the concept of max or the min heap, or in general heap, then it would be a bit trickier question for you. But if you know the concept of heap, it would be an easier question. Okay, so if you have any doubt, please feel free to ask, and the question link and the code link will present at the description. Okay,